Let's do a quick review of trigonometry, and it will help you work out the stuff on today's worksheet. So the three functions we're using are sine, cosine, and tangent. Say those with me. Sine, cosine, tangent. Wow, that was so good. So don't say sin, cos, tan. Those are just abbreviations. I'll give you a new nickname. All right, so the sine is the opposite side divided by the hypotenuse. The cosine is the a over h, and the tangent is o over a. And we remember that with the mnemonic so, ka, toa. So, ka, toa. Some? Way to go. All right. So let's say I had this triangle here. So last week we talked about, so we would call this, say, A and B. The sine of B, what does it equal? Well, first we have to place theta over here with B, and that makes this the hypotenuse. Well, that's always the hypotenuse. And 1 is the opposite side, and root 3 is the adjacent side. So the sine of B is 1/2. Now, the crazy thing about this is I didn't even need the triangle to figure that out. I could have just asked my calculator, what's the sine of 30 degrees? So pull out your calculators. Well, this only works if you know how big the angle is. If you don't know the angle, then you need the triangle. Everybody push mode on their calculator, right here. There are two ways to measure angles. One is called radians, which you've never heard of. The other is called degrees. I will teach you radians in the next chapter. Radians make a lot of mathematical sense in the theoretical world, and in the practical world, radians are totally useless. So if you're going to build a house, you're going to use degrees. It makes more sense. Radians, they're just terrible numbers. Most of them are irrational. So, well, you'll see when we get there. So make sure on the third one down that you highlight degree and you push enter. Then exit out and ask it what the sine of 30 is. Sine's 2 numbers above 7. Sine of 30. Now wait a minute. Something weird's going on. Wait, you figured it out? You're so much more helpful than I thought you were. So the calculator knew that the opposite divided by the hypotenuse was 1/2, and it didn't even know how big the triangle was. Right? So even if the triangle was 10 times bigger, so if I times each of these by 10, the answer is going to be the same. So the sine of 30 is now 10 over 20, which is still 1/2. I could add another 0. And it's still going to be 1/2. And that's the great secret of trigonometry. The ratios of the side lengths of right triangles have nothing to do with the size of the triangle. They're linked to the angles. So the sine of 30 is always 1/2. Even if your triangle is small, middle, huge, it doesn't matter. That's the trick with trigonometry. If that weren't true, then we wouldn't be able to do most of the things we do in trigonometry. Which you think is a bad thing, but you really like your cell phones, they use trigonometry. Yeah. If that relationship didn't exist, we'd be out of luck. So, we can ask the calculator what any ratio is. What is the sine of 60 degrees? Well, type it in. Sine of 60, 0.86. You should close the parenthesis. If you don't close a parenthesis, then the calculator automatically goes to the end of the calculation and closes it, which if you only have one calculation is not a problem, but if you actually have parentheses, it can mess things up. So sometimes you have to be a little bit more careful. Well, what is the sine of A? How would I calculate the sine of A? What would the ratio be for the sine of A in the triangle? So sine is O over H. So O is root 3 divided by 2. And I can check that. The square root of 3. And then divide the answer by 2. It's the same thing. So this is going to allow us to do something tomorrow. If you know what the angle is, you can automatically figure out what the ratio is just by plugging it in your calculator. If you know the ratio, there's a really easy way to figure out what the angle is. So if I knew that the ratio was root 3 over 2, I can ask the calculator to tell me what the angle is, and it will tell me it's 60. Okay, and that's for tomorrow. But today, we're going to look at knowing one angle and one side. So I have a right triangle. This is 30 degrees. Let's say I know that H is 24. How big is X? Well, you should be able to figure that out without a calculator. What did we learn about the sine of 30 degrees? It's 1/2. So X has to be half as big as 12. Or 24, which is 12. Thank you. So in this triangle here, we realize that if theta is 30, then the opposite side is half as big as the hypotenuse. So if I go forward, well, not every angle is so nice. Let's draw a new triangle, 48 degrees. Let's say this is X and this is 15. There are 3 pieces of information, one of which I don't know. What side do I not know? What's the name of that leg? Adjacent. And which side do I know? So the adjacent is unknown. The hypotenuse is known, and I know what the angle is. So what trig ratio am I going to use? Cosine. That's theta. Does everybody see its cosine? So, TOA. So the question is asking me to find the adjacent. So I need to use that. It told me the hypotenuse. So I know nothing about the opposites, so those are out. It's the cosine. So we're going to do a little bit of a trick. The cosine of 48 will tell me the ratio. So I'm going to write the cosine of 48 is equal to the ratio x over 15, a over h. Well, I need to solve for x, and then I can put it in my calculator. How do I solve for x? Well, you will, but we're going to multiply by 15. So the answer, x, is 15 times the cosine of 48. So 15 times the cosine of 48. And all that's really doing, don't do this, but I just want to show you guys what's happening. The cosine of 48 says 67%. So whatever x is, it has to be 67% as long as h. So all I have to do is 67% times h, which is what I calculated, 15 cosine of 48. Now, you don't actually have to think about that. Just set up the equation and solve for x. Now, there are two types here. This one we're going to refer to as a multiply problem because the x is in the numerator. If I multiply the denominator, I get x by itself. But in a different problem, let's say I had 3 and x, and this was 12 degrees. What are the two sides I'm dealing with? Opposite and adjacent. Adjacent touches theta and opposite does not. So you need to start by labeling h. This is h. The long one is h. And then adjacent touches the angle and opposite does not. If I move theta over here, then the O and the A will switch places. So adjacent literally means next to. That's what the word means. So this one is opposite over adjacent, which is what ratio? Tangent. So I'm going to write out the tangent of 12 degrees is equal to what ratio? 3 over x. Now, I'm going to show you how to solve this, and then you're never going to do it again because there's a faster way. I need to get rid of the x. So I'm going to multiply by x. Now I need to get rid of the tangent of 12. So I'm going to divide by the tangent of 12. And essentially, all I did was switch places with those. And that will work every time. So now it's 3 divide tangent 12. 3 divide the tangent of 12, 14.1. Okay, so there are only two types. When you set up the ratio, you will either have a multiply problem or a switch problem. Now, it might be sine or cosine or tangent. It just depends on what they give you. But it breaks down into one of those two options. 68 degrees. What ratio should we use? Opposite and hypotenuse, which is a sine. So the sine of 58 is equal to 68 is equal to x over 5. Is that a multiply or a switch? Multiply. So 5 sine of 68. Okay. How do I know 4.6 seems like a reasonable answer? It's got to be smaller than the hypotenuse, and it's got to be pretty close to the length of the hypotenuse. If this is 68, the other one, if we subtract those, is 22. So the smallest angle is opposite the smallest side. The largest angle is opposite the largest side, and the middle is there. So if this is 22 degrees, my triangle is probably actually something like this. And if that's theta, my opposite side is really close to the length of my hypotenuse. And my adjacent side is quite short because that angle is so short. Okay? So we would expect, if I called this y, and I did the cosine of 68 is y over 5, I would expect that number to be a lot smaller than 4. Because the angle it's attached, the angle it's opposite is so small. So it would be 5 cosine of 68. That side is really small because the side opposite is also really small. Okay. What about this one? What ratio am I going to use for that? So here's theta. We always label h. And then opposite is the one that does not touch theta. So this would be opposite, and this would be adjacent. So always start with H, then label your O and your A. Tangent. Tangent of 44 degrees is equal to 17 over x. Multiplier switch. It's a switch problem. So we switch places with those. X is 17 over the tangent of 44. Now before we solve it, what would we expect it to be? Bigger, why bigger? Well, this is 44, so this is 46. So 17 is going to be what compared to x? 17 will be smaller, a lot smaller, a little bit smaller, just a little tiny bit smaller, because the angles are nearly the same. So we would expect 16 point something. 17 divided by the tangent of 44. So the new side is just slightly bigger than the original side, which is what we expected. Oh, I said 16. I went in the wrong direction. Sorry. The new side is slightly bigger because the angle it's opposite is slightly bigger. So when you get an answer here, you should be able to judge every time and say that answer makes sense or it doesn't make sense. Okay? You got it? Good luck.